So from previously, in the calculator, 10 times 2 to the 8th was 2,560, would be the population after 8 years. So now going on to the next page. Now we have word problems that we're trying to generate an equation for and then use it to answer some questions. So I'm going to zoom out a little bit so I can see all of it in one problem. So example number 3, in the last 12 years, an initial population of 38 buffalo in a state park grew about 7%. So first, is it growth or decay? Well, since it says it grew, I know that it's going to be a growth. And then we're going to use the formula from the previous page, y equals a times 1 plus r to the t, because it's a growth function. Tomorrow we'll do the decay. A value is your initial population, your starting amount. So it says the initial population was 38. So 38's here. And then the rate is 7%. But we don't want to put it as a percent into the equation, so we change it to a decimal by multiplying by 100. All that's going to do is move it over twice. So R is 0.07. So plugging it into the formula, we get A is 38. So 38 times 1 plus R is 0.07. And we don't know what time is for the model, so we just leave it as t. So adding those together, 38 times 1.07 to the t power. So this would be our growth factor if that's what it asks for. It's the entire base, but we really don't need that part here. For part B, it says use the model to estimate about how many buffalo were in the state park after 7 years. So the 7 here is giving us the time. So we're going to plug this in for t. So we take our equation that we made, 38 times 1.07, and we plug in 7 as the exponent. And then this one we just type in the calculator to get the y value. So 38 times 1.07 to the, we use the caret sign, and then 7 tells us that the decimal is 61.02. But we're talking about buffalo here, so we just round to the nearest whole number, and we say 61 buffalo. All right, and then the last part C, using the graphing calculator. So when it says that, I want to put it in the y equals. We're going to estimate the year when they were 53 buffalo. So in the y equals, y1 equals, we want to plug in our equation, not this one with the 7 in it. We want to plug in with the x. So we're going to do 38 times 1.07 and an exponent of x. So over here, we do y equals, oh, look, it's already there. 38 times 1.07 to the x power. And then we're looking at the table. You could use the graph too and estimate the 53. But looking at the table, if we come here, we want to see when the y first passes 53. So right here, 53 is that decimal. And I would estimate this to be 5. So t or x is 5 years. So at 5 years, that's when there's about 53 buffalo. Maybe not exactly, but about. All right, and then the last example, again, it's giving us the word problem. So we use the word problem to make the equation and then answer the questions at the bottom. So clear this, because I'm going to need it. And clear this. Okay, in 1996, there were 2,573 computer viruses and other security incidents. During the next 7 years, the number of incidences increased by about 72% each year. I want to know first, is it growth or decay? So since it says it increased, we know it's growth. So then we do the equation for growth, y equals a times 1 plus r to the t. And then we got to find the other numbers here. So the a value was the starting amount. So in this year, they started with 2,573 incidents or viruses. And r is the 92%. So as a decimal, it would be 0.92 because we move it back 2 places. So plugging everything in, a here, so y equals or n equals 2,573 times 1 plus r is the 0.92. And we raise it to the t power. You can make it as x if you want. It really doesn't matter. So then we add these together. So our equation is 2573 times 1.92 to the t. So we just add 1 plus 0.92. So about how many incidences were there in 2003? So here we want to figure out what t is. So if we're in 2003 and it started in 1999, how many years away, or 1996, sorry, how many years away is this? So from here to here, we would say we would just subtract 2003 minus 1996. Tells us that it was 7 years away. So that's what we're going to use for t is 7. So we just plug it in and we get 2573 times 1.92 to the 7th power. And then again here we just type it in the calculator and we round to the nearest whole number because we don't want decimals here. So 2573 times 1.92 to the 7th power. And we get, so I would erase the decimal part and we only want to write this part right here. 247,484. So 247,484 incidences. So all right, last one. Use the table to estimate the year when there were about 125,000 security incidences. So we take this number, and this is what we want y to be. So we're going to look at the y equals again. So in y equals, we plug in our equation, this one with the x in there, not the one with the 7. So 2573 times 1.92 to the x power. And we look at the table. We want to see when it gets above this. When's the first time it's above this? So just moving down. So this one is the first time it's above 125,000. So we want to say that t equals 6 years. So all we did was took the equation and put it into y1. And we saw when the first time it was above. All right, so those are growth models. Decay, we're going to do tomorrow. It's when it decreases or declines or anything like that, depreciates. But today, they're all growth functions.